Alrighty, so today I'm talking about a wave equation in physics, and this one is just going to be V equals lambda and then frequency. And I'll get to a side note on that in a bit. So this is lambda. This stands for wavelength, and then we have frequency here. Frequency, and this velocity is the velocity of the wave. And so that's how we use the equation. Also understand that you can rearrange this equation. So if I need frequency, once again, I'm going to take velocity and divide that by um, my wavelength to get frequency and change it in terms like that. Let's see. I have another equation I'm looking at here. Oh, so I want to talk about this velocity. So we have two velocities that we'll really work with, and then I'm going to talk about how these velocities change. So we have sound waves that we talked about. Those are going to be your longitudinal waves. And then we have light waves. These are, so once again, transverse, and these are longitudinal. Oop, I got that backwards. Sound waves are longitudinal, and light waves are transverse. And so sound travels at, as far as our physics course goes, at 343 meters per second. And I believe this is at 20 degrees Celsius air. And this will change. So this depends on the medium. The speed depends on the medium. So what the wave is traveling through will change the speed of it, which will have an influence over the wavelength and frequency. And then light moves at 3.00 times 10 to the 8th meters per second. This is also in air. Light changes differently. So I want to talk about how they do change. So sound changes. In general, when it's more dense, it moves faster. Because if we think about how the wave works, it's compressing like this. So in a very tight substance, so in water and in metal, sound travels faster. Because those molecules are tighter compact and it is a longitudinal wave, the collisions happen faster, so sound is able to travel faster. Light is different. So sound travels better in solid objects. Objects. And then light is kind of the opposite. In air, it travels fast, but in water, light travels slower. This is why we see refractions, or if you put your hand in a thing of water, it looks different. So more dense, and light travels slower. So in space, light is moving the fastest because there's nothing there. And then in water or something, it's very dense, so it doesn't move that fast at all. So that's kind of the wave equation in physics and this velocity, and then understanding that when we do this equation and we're given a wavelength or a frequency, we can find the wavelength, but we got to know our velocity, and that velocity, understanding how that's going to change based on the medium that the wave is moving through. I hope that was helpful.